Good day everyone and welcome back to the channel. In this video we'll be continuing with the Euclidean geometry topic and we'll be diving into theorem 2 of proportionality. Okay, so in the previous video we already spoke about theorem 1 and we obviously displayed it and dissected it and explained it thoroughly. So we'll try to do the same in this video. Okay, so without wasting any further time, let's jump straight into the video. So theorem 2, which is the midpoint theorem, states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side of a triangle and half the length of that side. Okay, so now obviously this is very difficult to kind of visualize, and lucky for you guys, you have me to help you visualize it. Okay, so let's look at a visual example of what this theorem basically states. Okay, so now we have triangle ABC and we're told that DE is a line that cuts the line AB and AC into two equal parts, so it basically bisects it. Okay, such that AD is equal to B. So let me just write that down, such that AD is equals to DB and AE is equal to EC. Okay, so that's the information that we're given. If we're given that information, then what midpoint theorem basically states is that we can now conclude that this line, which is DE, is parallel to the third line, which is BC. So we can conclude that it is parallel to DE is parallel to BC. But not only that, we can also conclude that it is half of BC. So meaning that DE is equal to half of BC. Or you could just say that 2 times DE is equal to BC. So if DE was X, then BC would be 2X. Okay, so that is basically what the midpoint theorem is trying to explain to you. That if we have a line DE and we know that it bisects AB and AC, then we can conclude that line will be parallel to the third line, which is BC, and also will be half the value of BC. So that's not the only thing that we can conclude about the midpoint theorem. Okay, so let me just erase here so I can also explain what else we need to conclude about it. So now that we've concluded the midpoint theorem states that D is parallel to BC and it's also half of BC, what we also know is that if AD, not actually if AD, what basically the theorem states is that AD over AB will be equal to AE over AC and will also be equal to DE over BC. And from the midpoint theorem, we know that DE over BC is equal to half. So meaning that AD over AB, AD being this line and AB being this whole line, okay, then we can conclude that also that will be equal to half. Okay, so let's do an example to show all the calculations or show all the workings of how this theorem goes about. Okay, before we do an example, let's talk about the converse of the theorem. So now what we're told is that we have a line DE, and we're given that that line obviously is parallel to BC. But not only that, we're also told that it cuts AB into two equal parts, so meaning that it bisects it. So D would be the midpoint of AB. So the converse basically states that if that is the case, if that line DE does bisect one side of the triangle and is also parallel to the third side, then we can conclude that it also bisects the other side, which is AC in this case. But not only that, we can also conclude that DE will be half of BC. So if DE is X, then BC will be 2X. And that is the converse of theorem 2, the midpoint theorem. So now let's look at an example. So we're given the following information. I didn't write it down. I just displayed it visually. What we're given is that DE basically bisects the line AB. So it cuts it into two equal halves. But we're also given that AD is equal to 3. And we're also given that BC is equal to 8. And EC is equal to 12. We're also told that DE is parallel to BC. Okay, and now they want us to find or calculate X and Y. So now let's apply midpoint theorem and its converse in order for us to get the other side. So the first thing that we can conclude or deduce is that DB, since it's equal to AD, is also 3 centimeters. Okay, so now we can also conclude that AE is equal to EC. Okay, and the reason for that, and in this case it would be equal to 12, and the reason for that is because of the converse of midpoint theorem. Converse of midpoint theorem, where we're given the parallel that D is parallel to BC, and we're also told that it bisects one side of the triangle. So if that's the information that we're given, then we can conclude that obviously AE is equal to EC. So meaning that the value of AE or the value of X would be equal to 12. Okay, so we found one side using the converse of the midpoint theorem. So what we also know now about the midpoint theorem is that DE, actually let me try to use a different color, DE is equal to DE is equal to half of BC. Okay, and we're already given the value of BC, so meaning that DE will be equal to half of 8 units, and half of that will be 4. Okay, and the reason for that is because of the midpoint theorem. Okay, so we didn't really need to do much calculations. We just needed to know the converse of the midpoint theorem and the midpoint theorem in order to find the value of the other sides, which is X and Y. Okay, so these are the type of questions that you're going to get. Obviously, they're going to be more complex and integrated with other theorems of Euclidean geometry. But basically, in simple terms, this is how a midpoint theorem looks like, or this is how you basically apply a midpoint theorem to calculate the value of sides. So I'm going to end this video here so that it's short and easy for you guys to digest. And in the next video, we'll be talking about theorem 3 of proportionality. So that is it for this video. Please don't forget to like, share, and subscribe. And join our weekend classes where we will be talking or doing papers or past papers related to the information that we're going to be given for this week and this information, or that information also includes this video. So join our weekly sessions and weekend, sorry, not weekly, weekend, every Saturday at 10 a.m. The link is in the bio. You can join if you're a matric student and obviously are aiming to get great marks in matric. So I will see you in the next video. That is it for this video. Cheers.